I'm actually going backwards on this headstock, and I've been forced to do something which I definitely wanted to avoid doing. What could it be? Well, that's a bit of a nuisance. I've left this lathe without doing anything to it for several days, and I see that there's some oil dripping down there, and it's coming from this here. You can see there's a drop. This is the output shaft that sends the drive to the feed gearbox. According to the parts diagram, there should be some O-ring in there to stop that happening, but it's not working, so I guess I'm going to have to take that off and check that out. The other shaft that's below the oil level is this, which is the input pulley, and that is not leaking, so that's at least one good thing. Problem is that right down there is the shaft that I need to get out, and there's a gear that slides on that shaft, but there's a circlip on the end of that shaft, so I can't get it out without removing that circlip, and it's far too deep down there. So to get at that shaft, I definitely have to remove the spindle, which I think can come out that way. But to remove the spindle, I probably have to remove this shaft. Don't think I have to remove that. And then to get to the spindle down there, I might have to remove those gears as well. It's quite a major operation. Well, I've removed the 4 screws from this labyrinth seal here. That's the spindle. So that it's free to come out that way, and I've taken this locking nut, the one that sets the preload or the end float on the spindle, off, and I had assumed that the inner race of this bearing would then just come out fairly easily this way, but so far I've not found any way of shifting it. This has to be a slip fit on this shaft, doesn't it? Because otherwise, when tightening this up, it wouldn't change the end float. And it seems to be firmly fixed in there. So that's the inside of the bearing. The only practical way I can see of encouraging it to come out is to hit on this inner race there. I was thinking that if I remove this circlip from here, then this whole gear can stay more or less where it is, and the spindle would slide out that way, assuming I could get this bearing loose. But at the moment I can't get this bearing loose. Right, well, I managed to get a little end play in it now by virtue of hitting the inside of the inner race with this copper drift. But I have to hit it quite hard. I think I better take this circlip off now, or get it over this way. Right, well, I've got the circlip off, and it's up there now. It's funny, even when you have a bespoke tool for getting circlips off, it's very difficult with these big circlips to do it. And in the end, I had to do it with using a couple of screwdrivers and levering it off bit by bit as well, which is not ideal. Anyway, this is now loose, I'm happy to say. So we should be able to pull the spindle out that way if I can just get the rest of this bearing off. Well, I'm still knocking this off with this drift. I'm trying to. Not sure I can actually get it correctly. No, it's such an oblique angle. Before we go any further, let me just point out that afterwards I read some SKF PDF files about how to install and uninstall bearings, and they are very insistent that you should not use soft metal drifts like brass, or in my case copper, because they tend to shed shards into the work area. And also you should not use hardened steel punches, because they are likely to damage the bearing. So only use mild steel drifts is what they say. Nevertheless, I used this copper one because I read the document afterwards rather than before. Come on, wouldn't you like to come out now? Yes, I would like you to come out. This is what the chuck end of the spindle looks like at the moment. That's obviously just the what is that? The labyrinth seal. That's the labyrinth seal. And that's the rollers of the bearing, which look absolutely fine. Well, I got the spindle out, but I didn't have the camera on whilst I was doing it, and I had to hold it, so I couldn't switch the camera off. So we've got this gear is sitting down here. The other gear I've taken off. That's the circlip I wanted to get off in order to remove this, prevent this leak. And that's the back bearing of the spindle. Which looks absolutely fine. Front spindle bearing, however, doesn't perhaps look quite so good. Let me get some light. This is the outer race of the front spindle. See, it's got curious markings on it here. It is in fact perfectly smooth, but it's just got those markings in this quadrant here. In this quadrant here. They're not really present anywhere else. I think this black line here is caused by some hard material getting into the bearing and being rolled in, causing a dent in the raceway. But that's the only one that I can see around the circumference of this. As for this large-scale damage here, which doesn't seem to be regularly spaced. It's slightly regularly, but not really regularly spaced, and it's not right the way across the width of the raceway. I've been reading Timken and SKF bearing diagnosis documents, and I'm thinking that it's like a bit like this. This is a Timken document. Micro spalling, insufficient or a complete lack of lubricant. Here's an SKF one, which seems quite like what we've got there. Again, inadequate lubricant film. And this is interesting because in the previous edition I was pointing out that there seemed to be a lack of lubricant to the front headstock bearing, to the front spindle bearing. So possibly this damage is caused by lack of lubricant. I don't know. It feels completely smooth to the touch, but then I can't get a microscope on it. Evidently this is going to get worse as time goes on, but it's you know, it's kind of bearable at the moment, is my opinion. Well, that's where the inner race bears. So what I've been doing is moving this round and looking at the rollers. The rollers themselves look okay, but from time to time I notice something rolling around which looks like a bit of metal. I just have to go on till I find one on camera. Well, that might be one. If I take a completely clean finger, get hold of that. A very tiny piece of metal there. Well, that's interesting. You see a bloody great thing on my... I'm not quite sure where that came. It's come off from the vicinity of this, isn't it? So there's 3 bits of metal, one big one, one medium one, and one very tiny one that I've found on that front spindle bearing, on or in the front spindle bearing. Whether that is swarf that has got in and been mashed up, or whether it is coming off the race, I don't know. Right, well here's a magnet that I've carefully cleaned with blue tack, so it's got nothing on it. And this outer race is magnetic. So the question is this swarf that we found in the bearings magnetic? I don't think it is. Actually, the cage is not magnetic. This is the cage of the back bearing. I wasn't going to take this apart, but it fell apart in my hand. We go from bad to worse. Anyway, so this is not magnetic, so it's possible that the cage on the front bearing is where the swarf came from. This is the inner race of the back bearing, which we can see now that all the rollers have fallen out of it. We can see it, and I don't think there's anything wrong with that. Of course, These bearings are carefully selected, costing £743 each, carefully selected for minimum run out. And now that I've randomised the order of the rollers because they all fell out, God knows what the run out will be now if I put those rollers back into the cage. We live and learn. Well, I'm just putting this bearing back together again. Each roller is slightly tapered, so we have to get them the right way up. None of these rollers are damaged at all. So that goes like that, and now I think I put in there, and then what I realised is the whole point of this thing, this plastic ring, is to stop the bearing from falling apart when it's not in its outer race. So that just holds that on there. I think I put that on upside down, haven't I? You idiot. I suppose they all go the other way around? Can't believe that. Is it because each one of these looked... See, I could put that... Try it the other way round. So I was putting the wide bit at the bottom because it looked like that. I'm going to put the wide bit at the top this time. For goodness sake, what am I doing? I'm putting the wide bit at the top. Right. That looks better. That actually looks right, doesn't it? Thank God for that. Go on, go on. Right. Got it back together again. Well, this is the shaft that was leaking. And if we look at it from around here, I've got to get that circlip off. Right, well, I've got that circlip off, but there's another one there. But I'm thinking that if I undo these screws, this whole unit will come out like that, and this gear will just drop off the shaft. Where is that thing? Would you mind coming out? Yes. Thank you. That's what we wanted in the first place. Ow. Right, that's the gear. Well, now that I can see the bottom of this, it seems that it's not as clean as I would have liked it to be, even after my flushing with kerosene. Well, there's an O-ring here which I thought was just kind of sealing this flange to the case of the headstock. I don't know what's supposed to be dropping oil coming out of, stopping oil coming out of here, coming through the shaft this way. So I'm going to take this off. It's a funny thing about circlips, despite having special tools to get them off, they hardly ever come off easily, or indeed at all, do they? Right, let's try this again. I still don't know what, I'm left-handed, so I've got to do it like this. Perhaps this tool is just too bloody cheap. I just want to get under that so that it can't renege on me. You can't renege on me now, little rat. Come on. That's it. Now I can get it off. Right, so after the circlip comes a plain bush, and then the shaft will come out. Doesn't look to be anything wrong with the shaft. What I don't see is what this no, this is a rubber seal here, isn't it? Maybe I could have replaced that. No, I couldn't replace it because I'd have to take the shaft out, and to take the shaft out, I'd have to take that off, etc. So, but this is a rubber seal, a proper shaft seal. I don't know if the camera can see that. It says G2432 INA. The seal bears on here, which looks all right. I mean, it's not rough, it's just polished. I imagine this will come out by the crude technique. Yes, it's a single lit seal, and boy, is it absolutely rigid. I can just put my fingernail through it. So that explains why it was leaking. Right, well, I've taken this O-ring off because I might as well replace it while I'm about it. That just seals the flange. And the only bearing in this thing is just a long, doesn't actually look like bronze, but I don't know what kind of, two sleeves in there, which just slip on this, like that. Well, I'll have to order one of these, and we'll put it back together again when I've done it. Now, after all that, I've realised that actually I could have replaced this oil seal without removing this shaft, because I'd kind of assumed that this spline was part of the shaft, but actually it isn't. It's got a taper pin fixing it on, and this is just a kind of thick washer. So if I'd taken those two off, this is where the this shaft seal goes on here. I could have hoiked that out and put a new one in without all this bother. So once again, my lack of not being sufficiently observant has stood me in bad stead. Well, that's where I've got this week, and I can't help feeling I'm going backwards rapidly. Those spindle bearings are high quality ones which cost £743 each, because presumably they've been selected for ultra low run out and so on. And the front one seems to have a significant problem on the outer brace of wear, and the back one I accidentally completely disassembled into its individual components. And although I put it back together again, whether its run out will be the same as what it was before, given that the rows are now in an entirely different order, is a highly moot point. So all I can say is that this is the first lathe I've ever disassembled, and I'm educating myself and having fun and learning things and making mistakes. These videos are not supposed to show you how to do sensible things, because I don't do sensible things. So you just have to take them as they come, and we'll hope for the best. My general feeling is that until I've been able to take some cuts on this lathe and verify that the ways are not seriously worn, and I think they are seriously worn, there's no point in doing anything about the spindle bearings. I'll just put them back together again, and they will last, I feel sure, for quite a long time anyway. So I'll do that, and we'll get some power on the lathe and take some test cuts and see how badly worn the ways are before I take any more other decisions about that. Anyway, thanks for watching, and I don't know, tolerating my incompetence, I should say. So I've had a little progress with installing 3-phase in the workshop, but it's not live yet. I've got to persuade the electricity retailer to change the meter, and that I've been trying to do that since the beginning of November without any success. But that's another story.